Hello guys, welcome to Network Tips. Today we're looking at network fundamentals. We'll be diving right into network basics, getting to know what TCP/IP and IP/IP layer model, TCP/IP layer model, Internet cabling, then also Cisco three-layer model versus the span and tree leaves. So having said that, let's dive right into today's topic. So what is network anyway? So I want you guys to think about, anytime you hear about the word networking or network, just think about it as communication, means of communication. But before I dive right in explaining what networking is or what network is, I want to take you back to the old days where horsemen delivers letters via horse. So they run from one city to the other city. Let me take for example, you want to deliver a letter to your friend, you're going to write a letter, give it to the horseman will run tracks and they down to so location and deliver your letter to you. So but things evolves. We no longer have the horsemen. The horsemen they got better. They now have we writing letters. We deliver it. We send it to the post office. The post office will now be the people to now maybe deliver it via bike, the post bike guys, or via a car, depending, or drop it on your mailbox on your home. So, but also things, uh, more requirements are coming in. We start seeing organizations having needs to communicate to different branches that they have, maybe branch A, and also, oh god, my writing is terrible, pardon me, I don't have my writing pen. Branch B. So, and also even having needs to communicate to their external vendors as well. So these needs start arising, and imagine banks now that has multiple branches, and they want to send a letter or a message to their other branches. They have to send it to post office, and before it gets to post office, it might take days before it gets that one. So what's the downside of these things, of this old modern way of communicating? One, it delays, time consuming. Two, it's not secure, data integrity, it's not confidential. So reason why we need this modern way of communication is the speed. Now you can sit on your laptop, on your phone, on your smartphones, open your Gmail, your Outlook, send the letter there, and send it to so person you want to, your different branches, even your vendor. You can even blind copy different vendors, or blind copy and send it to multiple people at the same time. So you can see at speed which these things happens. So just split of seconds. So so this all about communication. So networking is it's all about it's about network collection of network devices being able to communicate with each other. These network devices can either be computers, can either be a computer, can either be a server, it can be a printer, it can either be your smartphones, your routers, your switches, your firewall. Be it being able to communicate with each other and sending packets and information across each other. So we have different types of network. um, or when it comes to networking, we have LAN, which is LAN area network. These are the type of network that you see within your within a building, or your room, or even your home your home as well. So these comprise maybe your router, your switches, your PCs, just a small build, just a building, your home, your room, or just these are just LAN type of networks as well. So we also have MAN, metropolitan area network. These are communication within an area or a city. For example, a very good example might be bank. For example, let me take for example Access Bank or Zenith Bank. Maybe they have multiple branches in Lagos, and they need the communication within those branches within within Lagos is what they call metropolitan area network. I think it shouldn't be more than, I think, 50 kilometers, 50 50 kilometers. Shouldn't be more than 50 kilometers or 100 kilometers. I think 50 to 100, 50 to 100 kilometers or thereabout. So these are MAN area networks. So moving forward, we have WAN area networks are communication on a large geographical areas, when branches, when organizations like Access Bank now started spanning over, they're now having their branches all over different cities. This might be, let me say, this might be Lagos. This might be Lagos. This might be Enugu. For example, this might be ABJ. For example, and the need for this, they will have a need for these different branches in these different cities to be communicating with each other. This type of networking, or this kind of network, is what they call WAN, wide area network. This can also range as far as different countries as well. So we have different types of network devices. The common ones you'll be seeing or be hearing in this course will be your switches, your routers, and your access points. You also have your patch panels as well. Yeah. Then these are not network devices. Then you have the old technology, the old devices you'll be seeing is your hubs, your bridge, and your repeaters. So these are more like the hub, the switch. No, the bridge is more like, they are more like an old modern of the switch. So switch is the newer model. So but before I dive right in, letting you guys know what a switch is or how a switch works, I would like to explain to you what a hub is. A hub. So a hub is a network device that has one collision domain and one broadcast domain. So it has one collision domain and one broadcast domain. So what did I mean by a collision domain? Collision domain is ability of, let me say, we have a PC connected to this port, and also have another PC connected to this port, and this PC, let me say B, and this guy is A. This PC A wants to communicate to this PC B. So, and this guy, let me say, you have another guy sitting over here, PC C. So ability of these guys sending, let me say PC A wants to send packets to PC B, and maybe PCC wants to send packet to PC B as well. So ability of then these guys communicating with each other without their packet being able to collide. So, but unfortunately, hub has a single collision domain. So these guys have to send packets to one after the other. So let me, you remember those days when we are small, we'll have this our normal cup here at this other end, someone will be on this other end as well. Yes, listening, have this guy here, we also have another guy here listening, and if you say hello, and this person over here will be able to hear you, but two of them cannot say hello at the same time because they can't hear each other. So one person have to say hello and the other person will be listening, and while this person is saying hello, this person will also be listening. So that's how a hub works. That's how it behaves. It has a single collision domain and one broadcast domain. So if they send their packet will collide, and if A is sending packet to B, C will also receive that information as well. So this is a no-no in today's world. Is not secured. So, and the broadcast domain is that brokers, you can, let's take brokers as more like talking to everyone. Maybe if I'm in a classroom environment, for example, in a classroom environment, I have you guys here. This might be my classroom. I have different seats here, and I'm talking to everyone, broadcasting to everyone. That's what broadcast domain is. Everybody. I'm not talking to any specific person. I'm talking to everyone. You understand? So, and yeah, that's what broadcast domain is. So this guy is going to hear you, this guy is going to hear you, this guy is going to hear you. It's not separated. So you can imagine when this thing start happening, maybe this guy will also be talking. Let me say this guy is also talking, this guy is also talking, this guy is also talking. What will happen automatically is that the classroom will get noisy. Nobody will be hearing each other again. So that's how hub is. Like, imagine your top management team members connecting to this kind of device, and everybody sending out a broadcast message. For example, a DHCP request is one of the example of a broadcast message. As we go on in this course, we get to find out different other type of broadcast message that we have. So a DHCP, maybe when a device wants to pick up an IP address, to send out a broadcast message and it to flood to everybody. You understand? It's not going to be in one domain. Everybody that is connected to this hub is on one domain. So everybody is going to hear it. Hey, I need IP address. So then A needs IP address again. You shout, yeah, I need IP address. B will shout, C will shout, I need IP address. B will shout, I need IP address. And what will happen everywhere will just, the network will just be a bunch of noisy place, and they start getting slow. So that's, broadcast message is not really a good thing. It's one of the things that cause slow connectivity on your network. So this hub is no longer have it again. So let's move down to a switch. So a switch has multiple collision domain and one broadcast domain by default. So multiple collision domain means that these devices can communicate to each other without this one receiving that packet, this one receiving that packet, or this one receiving that packet. You understand? They can be able to communicate to each other individually without them hearing each other. So it's more secure than the hub. But the broker's domain, it has one by default. So if you buy if you purchase a switch and keep it like this by default, all of them, when they are sending out a broker's message like that, this DHCP request that I said about earlier, everybody is going to receive that packet. But there's a way you can break down switch broker's domain into multiple brokers domain by default, and we get to find out as we move on in this course. So we also have our router. Router has it has multiple collision domain, and it also has doesn't forward any brokers. It breaks broker's domain. It does not forward any broker's message by default. So if you send any message that is broadcast to a router, the router is going to drop that packet. Maybe say, hey, I want IP address. You're sending the message, and that message mistakenly get to a router. The router is going to drop that packet. It's not going to send that packet. So it breaks out brokers messages. It doesn't forward brokers messages. So it's more like a roundabout. It's more each packet that comes to it routes it to another. It looks at its table and they find the best route where it can route that packet as well. You can see it divides network based on the network addresses. So by default, router interface also cannot be on the same network. Let me take for example, I know you don't know what a network IP address is or all those kind of stuff. So let me just take for example, I have one here. I have 1.1.2 here, and I have 1.3 here. Understand? Let me take for instance, this one is the ID, what is identifying that network. Router interface, the two of routers interface cannot have the same ID at the same time. It do not accept that IP address or that address, so you have to change it to some other address network for you to accept it. So that's what a router is, and that's how it works. So we also have, on the other hand, we have our access points. Our access points they are network devices that extends wireless connectivity to our mobile devices. So let me take for example, how will I put this now? And extend the wired network. You understand? Maybe for example, you're having your switch here, every other devices are connected to this guy, and maybe your MD over here is using a laptop or maybe a handset, and is having, I want my phone to also have to be connected to this network, but phones does not have network ports of what, so there's no way he can connect. So the only way you can do that is to make a purchase of an access point, an AP, and they have this mobile device connect to that AP, and it have extended this the wired network and giving access to your wireless devices, your mobile devices on the network. So that's what AP is, and that's how it works. So moving down to cabling, we have different types of network cables. We have the shielded twisted pair and the unshielded twisted pair. The shielded twisted pair are mostly used in industrial areas. You're going to see because it's withstand more it can withstand more damages or more impact on it, and it can restore more impact, is more compacted. You see it might have kind of a foil covered it, and it's more thicker also than the unshielded twisted pair. This one on the screen is more of the unshielded twisted pair. So the outer this plastic cover, or this the outer jacket is what they call the insulated jacket. Then we also have the the twisted pair cables. I know one of the reasons why they twist these cables is for it to avoid crosstalks, the signal of this one interfering with one another. We also have more like a PVC pipe that run through down to it, that separates this cable. It's not like this, so that's why it's called twisted shielded or twisted pair cables. So inside of it you have your copper wires, which is used for transmitting data. Then these cables are being grouped into categories. They have the Cat3 for short. The Cat3 mostly used for telephone or Ethernet connection. The speed mostly is about 10 Mbps, and the frequency it operates on 16 megahertz frequency. You also have your Cat5. Your Cat5, the network type is usually a fast Ethernet. It has a speed of 100 Mbps, and the maximum frequency of 100 megahertz as well. Then also have your Cat5e. Cat5e will have the network type as the gigabit Ethernet. You're going to have the maximum speed as up to 1000 gigabit per second, and also the frequency is going to be 100 megahertz as well. Then you have your Cat6. Cat6 will have it as a gigabit Ethernet, the speed as 10 gigabit per second. Then the maximum frequency you have it as 250 gigahertz, and this thing. The Cat6 also has Cat6e, of course, and you also have this Cat6a, then that has up to 10 network type as gigabit Ethernet, and also speed as up to 10 gigabits per second, and frequency at which this data will be transmitting is about 500 megahertz. Then you also have your Cat7. Your Cat7 we have it at we also have the network type as gigabit Ethernet. Then we have the speed, the maximum speed can operate at the speed as much as 10 gigabit per second. See that sign here, plus, so it's higher than these other ones. So we have the frequency, it can transmit data at the rate of 600 hertz. So the connector which we use in connecting these cables and terminating them before plugging them to the network devices is called RJ45. So this connected cable are just terminals, just terminal RJ45 register jack. That's what it stands for. These twisted cables has arrangement depending on the type of device which you want to connect to. For example, if you are connecting unlike devices, maybe for example your PC and your switch are going to use a cable arrangement, or a cable arrangement of straight through. You're going to prepare a cable in a straight through format to connect these two devices together. So you can see this RJ45 is an 8-pin terminal, but the most relevant terminal on this RJ45 that is used for transmitting data and receiving data is only 4. So you have your pin 1, your pin 2, your pin 3, and pin 6. Pin 1 and 2 is used for transmitting data, while pin 3 and 6 is used for receiving data. So so your if you are connecting more like the same device, for example your router and router, you're going to need a crossover cable to do that. So your crossover cable, why do we cross this cable? So you can imagine if these cables are using straight through, you're going to be transmitting data here and you are transmitting data here. Why this 1 and 2, you are transmitting to a transmit, and this one is also transmitting as well. Can you see? So like their packets, your packet is going to collide because you are transmitting to a transmitting point. You understand? The packet is going to collide and nothing will be happening to this receiving point. So that's why they decide to just cross these cables, and they will have these guys like this. So they also have another special one, which is rollover cable. This rollover cable are specially designed by machines as well. You're not going to be the one to crimp it. Of course, mostly this type of cable that uses one is your console cable. Your console cable I showed you earlier at the beginning of this course. So that's the type of cable that will use this one. So having said this, this cable, you are meant to know how the wiring diagram of this cable looks like. We'll have the American wiring standard, and we also have the British wiring standard. So you are going to prepare this cable according to this arrangement. So you just have to pick one standard and know which one. If you are conversant with the American standard, which is this one up here, and or if you are conversant with this British standard, just stick with it as well. I prefer using this British standard because that's what I started with. I never bothered looking at the American standard as well. So but whichever one you are doing with, just if you are designing an environment and you are using American standard, continue and follow the American standard. Don't mix it up with a British standard. So if you are, the same thing goes with the British standard. If you're designing a network and you're still up with British standard, follow on along and do it all British standard. So if you are designing, if you want to prepare a cable for a straight through, you can see this is what you are going to prepare. This is what you are going to prepare. This is what you are going to prepare. Then if you are designing for crossover cable, you're going to prepare this kind of one. So straight through, you're going to have your white, orange, your white, green, blue, your blue stripe, your green, your brown stripe, and the brown as well. Make sure these cables are properly arranged, trimmed, and then terminated on the RJ45. So having said that, these days most people don't even crimp cables anymore. So we have what you buy already crimped cable, or even if you want to crimp cables, you won't start memorizing memorizing the straight through and the crossover cable as well. This is just for exam purposes, and if factor is going to come out in the exam. But it's also good for you to know that it's such thing like this, and also for interview purpose, they might just ask you off in the interview. Then you just know which one to tell them. Then also you also have what they call auto detection mechanism, regardless of the one you prepare, whether straight through or crossover cable, is going to work in any device. So if you prepare a straight through cable and you want to connect router to router, new modern devices now has what they call auto detection mechanism, that they can be able to detect and reconfigure themselves on these stuffs. So having said that, we'll come to an end on this section, and I would like to thank you for watching. See you in the next video.